Actually, it's on. All right, we are recording. So find a conversion factor between cubic meters and cubic centimeters. Okay. So, 1 meter and so I'm asking this question to the group. 1 meter equals how many centimeters?
1,000.
Okay, so what does cent, C-E-N-T? Is that 1,000 or is
100.
that's 100? All right, so and it's the same. Just think about dollars. If I have $5 and what 32 what, and we say cents, C-E-N-T, and that means means 100. So that would be 100 centimeters. And I probably left it, and I left it back in my office. I wish I'd grabbed them. Give me 1 second. I want to look up something. Okay, so I'm going to grab the book and I'm going to try to put it into the camera. So do you remember the handout I gave you all? And this was one of the things I printed out. So if you have that handout handy, you'll see where it goes deci, 10 to the negative first, and then centi, C-E-N-T-I, and 10 to the negative second, which means, again, 2 decimal places. All right. Now, 100 can be written as 10 squared. You good there? All right, so if we're finding a conversion factor between cubic meters, excuse me, and cubic centimeters, right now what I have is meters to centimeters. So what I'm going to do is I'm going to take this and raise each side to the power of 3, which is cubic. You good there? And then we're going to apply exponent rules. So 1 cubed is 1. So 1 cubic meter. Now, exponent rule. Let's jump over here. If I have x to the power of n raised to the n power, this is referred to as a power rule. And I don't know why I wrote a 3 there. N times m. You multiply these two. So, and also exponent rule, if I have 2 things multiplied here all to some power, as long as it's multiplication, you can raise each factor to that power, then multiply them. So my point is this: I can then apply these 2 rules. 3 times 2 is what? 6. And then this is understood to have a power of 1. So that's centimeters cubed. Good so far? Right. So once I get this, I can look at on that quiz, you're given 4 choices. And I'm going to go ahead and write down what the 4 choices were. You had A, 1 meter cubed equals 100 centimeters cubed. That can't be. 100 is 10 to the second. So that knocks that out right there. Now there's some other stuff written, but it doesn't matter. This isn't correct. Your second choice was 1 meter cubed equals 10 cubed centimeters cubed. Again, this right here is not correct because it's ultimately 10 to the 6th. So that's not correct. And again, it has some other things here. C has 1 meter cubed equals 10 to the 4th centimeters cubed. Again, that's not correct. So literally the first 3 you can eliminate without even looking at anything else that's written past the comma. On D, they have 1 meter cubed equals 10 to the 6th centimeters cubed. Now, since you were able to eliminate the first 3, it's got to be this one. But I'm going to go on and look at what else they wrote. They wrote this: 10 to the 6th centimeter cubed over 1 meter cubed. And this is where we're using it like conversion factors, where this is just a factor of 1. Since these are equivalent, this over itself is just 1. And then the other one is just this flipped, which is still a factor of 1. And so this is your choice. But the reason why is, so whenever you're looking at either area with squared units or volume with cubic units, you first find what the conversion factor is to a power of 1, then raise each side either to the power of 2 if you're dealing with area, or the power of 3 if you're dealing with volume. All right, have I made sense? All right, is there another quiz question?
Probably number 8.
Number 8, all right. Oh, man. All right. So do you guys have those handouts handy that I gave you?
I don't have them with me. They're inside.
Okay, that's all right. You don't have to go get them. But because this one is going from metric to US customary units. And so you need to have that conversion chart to start with. I'm going to turn the page, if it's okay, off this one. All right. So again, it's little quiz 2. Number 8. And we're going from 8 kilometers. And we want to convert this to yards. All right, which is US customary. Now, and I would not expect you to have these tables memorized. Just, you need to table this. So I'm going to first, I've got to find the table. All right. All right, bear with me 1 second. I'm actually working the problem out. So, okay. Here's- Now we need- here's the- so, 3.2. Right, times. Oh. There's 10th. All right, so I apologize. I'm working the arithmetic on this. I came up. Huh. I'm using their numbers. Why did I come off there? All right, 8,000 meters. 1 meter is 3.28 feet. 8,000. Feet. All right. So I'm going to go ahead and work through. I'm off by literally 3 feet, and I'm not sure why. We want to go 8 kilometers to yards. So let's first convert 8 kilometers into meters. All right, so you guys tell me, how many meters? 8 kilometers is how many meters?
$8,000.
Yes, sir. That's it, 8,000. Okay, so if you look on the 3 sheets that I gave you, find the one that says table 2.4. And it's got USCS, United States customary standard units to metric conversions. So the one that says USCS metric conversions. So you have that one? And what I'm looking at that point is on that chart, 1 meter is 3.28 feet. So if I wanted to convert meters to feet, take my 8,000 meters, multiply that by then 3.28 feet over 1 meter. So my meters would cancel. And I would have 8,000 times 3.28. Now, that gives me 26,240 feet. According to my calculator. Now, we're wanting to go to yards. So in 1 yard, there are what? 3 feet? So if I take my 26,240 feet, and we're going to multiply this by 1 yard over 3 feet, which basically means I'm dividing this number by 3. Now, this is where I had the issue, and that's why I was pausing for a second. According to my calculator, this comes out to 8,746.6 repeating. And that's where I've got my issue. They give 3 answers here. Or excuse me, 4 answers here. 3 of them are way off. The answer that is correct is given to be 8,749.3 yards. And I haven't figured out you can see where my discrepancy is. This is off by about 3 feet. And I'm not sure why. Is that why you had a problem, or you just having trouble with how to do the conversion itself?
I had trouble doing the conversions and like I didn't find the answer at all.
Okay.
I think that's where I was confused.
All right. So I definitely know this is the right conversion calculations.
Okay.
That I'm positive of, but I'm just looking at the numbers that popped up when I pulled up this quiz. And so you can see I'm awful close, but it's not the same. Now, if you were to work it out like this and see, as I said, 3 of them, like one answer is 26,000 and something, another answer is 67,000 and something, and the third incorrect answer is 22,000 and something. But I can't account for, I'm not sure why I'm off off by 3 here, but I am positive this is the right, calculation.
Okay.
Um, so. So I'm missing something here. Um, give me 1 second. I want to try to see if I can find this particular problem in homework. So let me back up into 2B. Oh, let me do this. Two A 5-7. Great. All right, I found it. Okay, that wasn't the right one. All right, it's not fair. All right, let me try this. All right, so I'm definitely not finding this problem, this exact problem on the test. But again, I'm not sure why I'm off by the 3 feet. I know these are the
Okay.
correct calculations, and I'm using their conversion numbers, but that bothers me that it was off by 3 feet. But it is correct
Okay.
calculations. All right, is there another problem from the quiz?
Um, I think number 7. I just had a little bit of problem with it.
Number 7. All right, so you buy a hair product in a 9-ounce bottle for $1.35? Or,
Mhm.
okay. So. All right, you buy a hair product in a 9-ounce bottle. And for $1.35. Or in a 6-ounce bottle for 78 cents. Which is the better deal? And so what you would really want to look at is how much per ounce, per 1 unit.
Mhm.
And that's how you'd want to compare. Right? So we've got $1.35. I'm gonna put dollars here. 9 ounces or dollars per ounce. That's ultimately what I'm looking for here. So if I get my calculator, 1.35. That's going to give me 0.15. Or basically 15 cents per what ounce. Then I would do the same thing, $0.78 divided by 6 ounces. Now, generally, the rule is that, if you're buying something, the more you buy, the less per unit it is, generally speaking. But you can't always bank on that.
Mhm.
0.78 divided by 6, though, does work out to be $0.13 per ounce. So in this case, it would be the what? You're given 4 choices on your answer. 6-ounce bottle was one choice. 9-ounce bottle was the second choice at that price point. Equal value, and then one selection was not enough information. It's the 6-ounce bottle. The 6-ounce bottle, you're paying less per ounce for it, which is actually, again, normally it's the larger quantity you buy, the less cost per unit it's going to be. But in order to actually do it, you want to figure out what is the cost per that 1 unit. So whenever you get a problem like this, you'll just simply take the price, divide it by the amount to get that price per unit.
Okay.
Make sense?
Yeah, that makes perfect sense.
So in this case, it will be you'll definitely want, by 2 cents, but the 6-ounce bottle
Okay.
is the better deal. All right, another question from the quiz?
That's all I had.
Anybody else? Natalie, Adam, Aiden, Casey?
The one about the light bulb and the waltz threw me off again. It's the second part where it says that the watts change like from 100 watts to 10.
So 10, okay.
I don't remember what question it was. I just remember it was about the light bulb, and it's the second part that always gets me.
Okay, so it's number 6 on the quiz. And if you can get the first part, you've got it. So if you can do the first part, you've got the second. Um, all right. Give me a second here. Okay. So turn the page. So I'm going to have a 16 cents per kilowatt hour. And that's what I'm going to be charged to light my light bulb. And what we want to know is what is going to be the daily cost of keeping a 120, too many zeros, 120 watt light bulb lit for 15 hours a day, each day. And that's the first part. And that so you're okay on the first part. And again, if we can get the first part, we'll get the second part. All right. So what we're going to have to do to figure out what it's going to cost is first take my 120 watts. And at the end of the day, I want my units to be dollars. So I got to get everything to cancel out but dollars. Also knowing that the charge is by kilowatt hour and the light bulb is measured in the power in watts. So the first thing I'm going to do is convert that watts to kilowatts. So 1 kilowatt, kilo means 1,000. So that is 1,000 watts. That will get my watts to cancel out. And I'm going to keep this light bulb lit for 15 hours. And I'm going to have a rate of $0.16 per kilowatt hours. All right. So now in this string right here, so what we want to observe is how, okay, the watts cancel. Kilowatt cancels. Hours cancel. I'm left now with what? Dollars. And so it's literally 120 times 15 times 0.16. And that comes out to be 0.288. Which if you were rounding up to cents would be 29 cents an hour. Or 29 cents for the day, I'm sorry. So it's going to cost you $0.288, but again, 29 cents for 15 hours each day. Right, so that answers that first problem, but that would be what your string would look like. So the numbers are going to change on the quiz, and it would just be a matter of interchanging those numbers in that conversion string. Okay. Now, the second question is going to be, how much could you save, and not for a day, but for a year, if you replace that light bulb with one that only uses 12 watts of power? So to figure that out, first I need to figure how much is it going to cost to light up that 120 watt light bulb for the whole year, given that it's going to cost you this amount per day. So if I take my 0.288 dollars per day times now 365 days per what year? 1 year. Then I can get my days to cancel. So 0.288 times 365, you're going to be paying $105.12 per year. So all we need to figure up is how much per year is it going to cost me if I have a 120 watt light bulb. So what I'll do is, like when I said, if you can get the first part, you'll get the second part. Because all I'm going to do is figure this up again, but not for 120 watts, but for 12 watts. So you would have 12 watts times, again, this first one is just to interchange kilowatts for watts. So there's 1,000 watts in 1 kilowatt. Those will cancel. And then times the 15 hours times the 0.16 dollars per kilowatt hours. And then times the 365 days per 1 year. So I get the kilowatts to cancel, got the watts to cancel, got the hours to cancel, and I'm going to be left with, at this point, dollars per year. I'm going to get this also 12 times 15 times 0.16 times 365 is going to work out to be 1051. Dollars per year in the day. Dollars. All right. And then it's just at that point, just is traction. 105. .12 minus 1051 is going to give you your cost savings for the year, $94.61 for the year. Good. So the big on that second part of that question, if you got the figured out for the first part, you're just going to take the 120 out and put in its place 12 and figure out. And you could first figure out how much is it going to cost you per day and then multiply that by 365. And that would give you your cost per year. And then take the difference of the two. All right, another question? Going once. Twice. All right, so I am, lest I forget. All right, so I did change the due date for exam 1 to Tuesday. So my hope is you can work through everything else and take that test prior to class on Tuesday. If there are no other questions, I'm going to talk about percentages, but I'm more than happy to work any other problems out of chapter 1 or 2. Good.
I think so.
Okay. If you think of something here later before we head
Mhm.
out, that's fine. You can ask. Let me switch. So 120E, since we are going to look at the uses and abuses of percentages. What I want to do are just look at some arithmetic of percentages. And this is out of the 120E. And all right. And I apologize if you're an NFL fan. I think they probably have already kicked off.
8:20.
Okay, so we're not there yet. All right, I knew the first game was tonight. All right, so I'm gonna assign out of 120E. It's gonna be out of sections called 3.2. And there's some review problems to start, the first few problems, and then it gets into some percentages. So let's talk about percentages. Hopefully this is just review, but if not, we cover it. So there's your percentage symbol. The first problem says convert the percent to a decimal. All right, so it's just this simple with percentages. It's right in we have been dealing with these units and unit conversions, and we talked about per means divide by. And so when you hear percent, it literally means per 100. That's what a percentage is. It's just writing it as a fraction over 100. So when I look at the percentage symbol itself, that is a 1 and 2 zeros that have just been arranged differently. That's all. So if this is percentages and it says convert to a decimal, now you could also convert it to a fraction. Anytime you have 14%, it's just take that number and write it over what? 100. There's its fractional form, not reduced, but 14 over 100. And we know place value wise, 100 is what? 2 decimal places. So if you'd punch this in your calculator, you would get 0.14. That is, if I have 14% and it says convert to a decimal point is not seen, it's right here. Move it twice. That is, it is 0.14. And that's its decimal form. Are we good with that?
Is it because you're moving left?
You're moving left.
Okay.
Exactly. So, and you always got to be careful. Sometimes you'll get something like this, 0.03%. And if you convert that to a decimal, that will be 0.00. 0.03. Again, what did I do? I moved it to the left, 2 places.
Okay.
If you have a number in decimal form and you said convert it to a percent, then you move it to the right twice and then attach your percentage symbol with it. All right. So I'm just looking at that was problem number 6 on the homework here. Number 7 gives you 5.3%. Convert to a decimal. So we just remember what? Move it to the left twice. So 0.053, so that it moved 1, 2 places. And that would be your answer, 0.053. And, you know, life skills. You're at a restaurant and you got to leave a tip. And they were great servers. They did a great job. And they actually will now, if you look on a receipt, when they bring you the receipts, they generally put a breakdown. This is what a 20% tip would be. This is what a 15% tip would be. This is what a 10% tip would be. They put those calculations in there. But if I actually, you know, had to do that on my own, and I generally always go at least, you know, you have to be pretty bad. And even if you're a bad server, I'm still going to tip you. If you're rude to me, that's a different story. But serving's a hard job. But if I have to do that calculation and I had a bill of $41.82. So we all have these now, right? Like a phone. And on the
Right.
phone, you got a calculator, right? So you can grab that calculator. And do this. Now, I'm 20% tip. So when you want to figure out what is 20% of $41.82, then the calculation is take that percentage and turn it to a decimal. So if I move the decimal place twice in decimal form, that is 0.2. So I get my calculator on my phone and I go 41.82 times 0.2. That comes out to $8 and rounding down, it was 8.364. So now, what would I do? I would just probably round it to $9. I would round it up to an even number. But you could still write 8.36 right there on the receipt. But that's how you figure up the tip. And that is no different than if you are at a store that is having a 25-35% sale. And so you would take that, whatever the item's price is, if you want to figure out how much can I take off, let's say it was 35% sale. Then multiply that price by 0.35, that tells you the amount to take off. And you would subtract it from the amount. So, are we good with that?
Hang on. I don't know why it's just not clicking with me here.
Sure, you're fine.
You said it's 20%?
20%. So if you were figuring up a 20% tip on a restaurant bill, $41.82, then the way you calculate it is convert the percentage into decimal form. So 20% in decimal form is 0.2. I moved the decimal place twice to the left. Then multiply that by 0.2 times the bill. And that's what it came up to be, 8.36. So $8.36 is 20% of $41.82. So that would be a 20% tip right there.
Okay.
Does that make sense?
Yeah, I don't know why the number just didn't look right to me for a minute. I thought at first you put 18, but that was just part of the
Oh,
dollar.
that was that was a slash on the dollar. And I always put 2 marks on my dollar bill, my dollar sign out of habit. But anytime you're dealing with percentages, that's how it works. Again, as I said, like if you are just getting, buying, you're in a clothes store and they've got a 30% sale, then take you got this shirt you want to buy. And you want, so how much do I take off? Multiply that price by 0.3 in that case. That gives you then the amount what 30% of that price would be. Take it off that price and then But then if you have some type of savings account and it's got an annual yield of 3%, then you multiply how much you have in the account by 0.3. And that tells you how much interest you've earned. So, but to figure up a percentage of something, it's always put it in decimal form and then multiply it by that amount. And that gives you that percentage of it. All right, let me see if we got anything else in here. Now, just, this is going the other direction. I'm looking at number 9 on this homework. If I had 0.0385 and I wanted to convert that now this is going from decimal to percentage. So if you're going from decimal form to percentage, move 2 places to the right. Which this case would be 3.85%. Excuse me, percent. All right, I'm gonna give you guys a problem. See if you can work it out. Looking at number 12 of this homework. A naturalist said 1% of 1,900 plants in the park are poisonous. How many plants are poisonous? So if you have 1% of 1,900 plants, I'm not going to write the word poisonous. I'm just going to say are bad. How many are bad? That is poisonous. Right. I need the number. Out of that 1,900, how many would be actually poisonous?
$19.
That's it. 19. Multiply the 1,900 by 0.01. And that gives you 19. So it's the same calculation every time.
I put 2 zeros. Should I have that like this? Yeah. I just put too many zeros in mine.
Gotcha. So you gotta, that's where you just have to always remember just 2 decimal places. And so count them up.
Okay.
Yep. So just make sure you're careful on counting the number of decimal places. All right, let's see if there's any other weird problems in here.
Sure.
Is it that easy? It's really not easy. Ah, you'll like that one. All right. Let's do, here's another one that we haven't looked at. Now, we've already said a percentage is a fraction. Like I had 14%, that means 14 over 100, or decimal form of 0.14. What if you had this? So we're going to write the percent as a fraction or mixed number in lowest terms. So we got to write it as a fraction, not as a decimal form. And it's 17 and 1/5%. All right. So here we go. How are we going to get this one done? I'm going to write this as a whole number, proper fraction, or mixed number. So remember, this is percent, means what? Per 100, right? So I could write the 17 and 1/5. That's a mixed fraction, but over what? 100.
Over 100. Mhm.
Right? Now, I need to simplify this. So what I'm going to do first is put this top fraction in improper form. So remember, that would be 5 times 17 plus 1. So 5 times 17 is 85 plus 1 is 86. So 17 and 1/5 is 86 fifths over 100. Now, what I'm going to do from there is, remember, this would be like over 1. Over 1. So I could now take my 86 fifths and multiply that by 1 over 100. Good so far. Now I could reduce on this real quick. Certainly 2 is going to go in top and bottom. 3 would not. 2 will go into 86 43 times. And 2 will go into here 50 times. So in the top, I'm going to have 43. That's a prime number. And 5 times 50 is 250. All right.
Yeah.
I'm checking my arithmetic here. And that is the answer. Any questions on that one, arithmetic wise? So I took that mixed fraction, wrote it as a fraction because it was mixed fraction percent. So I wrote it over 100. I converted that to improper in the top, flipped the bottom, multiplied them. And what I did was I divided 2 into that and 2 into that. And that got me completely reduced. I didn't have to worry about reducing, because then I just had 43 times 1 in the bottom and 5 times 50, or excuse me, 43 times 1 in the top and 5 times 50 in the bottom. And I got my 43 over 250, which was the answer. Are we good?
So will you always divide like the 86, like what you did there for the 100 by 2? Or is that just like the divisible by?
It was just because that's what it was divisible by. I knew the top
Okay.
and bottom were both even, so I divided both by 2.
Okay, so it will be different then.
Oh, yeah. So
Different numbers.
like if
Okay.
this had been 80 and that had been
Mhm.
100, I would have probably tried 5 or 10.
Okay,
Yeah.
okay,
I always look for the largest factor if I can find it real quick between top and bottom. I
Okay.
chose 2 because they were both even. And yeah, so it'd always be a little different for sure.
okay.
All right, let me see if there's any others. Should be okay there. Okay, here's one we haven't looked at yet. Turn the page. we are going to write 18 over 25 as a percent. All right, so that is our goal. All right, so the easiest way to do this one is to get your calculator and go 18 divided by 25. All right, this is the simplest way to do it. So 18 by 25. So I literally on my calculator punched in 18, hit divide by 25. And what this gives me is the decimal form of this fraction. It gives me 0.72. All right, what is 0.72 as a percentage? I want to write this as some percent. What do? Move that decimal place to the what? Oh, that's backwards, isn't it? Camera. Right. Move it to the right 2 places because you're literally thinking of 72 over 100. So it moves, boom, boom. We're at 72%. Is that okay? So, I mean, if you take a quiz that was worth 25 points and you scored 18 out of 25 and you want to figure up your percentage, just take 18 divided by 25 and get your 0.72, and then you know, okay, that's 72%. That's what I scored. We good? Yay, nay?
Yeah, that makes sense.
Okay. All right, see if there's any others that are, that should be okay.
Can we do like a little bit harder number, Mr. Cunningham? If that's okay.
Sure, like what? What do you want?
I don't know. I mean, that makes sense, but if it gets harder, then I feel like I'm gonna have a little bit of a problem.
Okay,
Like moving the decimal and stuff.
let's see if there's anything. There's really honestly nothing more radical than that in the homework. Just kind of, that should not be, that should. Oh, I've locked up my computer. Okay, I'm gonna make up one.
Okay.
I'm gonna make it ridiculous. All right. What if I said convert 2,536 1,452 to a percentage. So we're going to write this as a percentage. Calculation will not change. Now, when you see that top is bigger than the bottom, first off, your answer is over 100%.
Okay.
All right.
Okay.
You're at 100% when the top and bottom of a fraction are the same. That's 100%.
Okay.
But calculation wise, I'm going to do exactly the same thing here as I did here. I'm going to take 2,536 divide by 1,452. And whatever I get. Now, I would probably also say write as a percentage and round off at 10th place. Because what you're going to get here, because I just made this one up, 1.746556455647.4. and then the cutoff, and there's probably more beyond that. But if I
Yeah.
said, write this as a percentage,
Mhm.
round to tens place. All right. First off, move the decimal place twice. So remember, I said this had to be over 100%.
Right. So would you move it to the right?
I would move it to the right. Did I say
Okay.
left? I apologize. To the right to turn it to a percentage. Left if you're going from percentage to decimal form. So 174. Now here's my decimal point, and then I said tens
Okay.
place. Since that's a
Okay,
5, I would round this one up to a 7, and then attach the percentage sign.
Okay.
But calculation wise, it's top divided by bottom. That gives you your decimal form. To put it in percentage form, move the decimal place to the right twice. And that is it. All right.
Okay,
So
thank you.
you're welcome. So on 128, I am assigning, working on it right now. You're going to see a new assignment. It's going to be titled 3.2, homework 3.2, 3.2 homework. I'm going to put the 14th as the due date, which will be Tuesday.
Mhm.
And now it is assigned. So there's nothing new in 120. Your 120 assignment is to finish things out and take that test, test 1, chapters 1 and 2 test by next Tuesday, before class on Tuesday. And then do this 120E stuff on percentages. And then on Tuesday, we're going to start class, and I'm just going to jump into 3A of 120, which again is entitled Uses and Abuses of Percentages. And look at how they're used, because we are bombarded with percentages every single day, for sure.
Use the text.
So that is the game plan. I'm going to give you a reminder, and I don't mean to be preachy or anything. It's just I care. That's all. Try to be safe out there. My friend that I talked about a couple weeks ago is fully recovered and back to
That's
work.
good.
Yes. But again, I hear stories from the hospital because of my wife. There's actually, I mean, couldn't give names or anything like that, but an infant with COVID in the ICU. And
That's sad.
yeah, and so anyway, and just before I came down to jump on here with you guys, my next door neighbors, I've got a 8-foot privacy fence around our backyard for our dogs, and they've got a chain link fence, and then it mates up to our fence, and they've got a pit bull mix and it's a big dog. Shoot, what's a big dog? It's a
You
beautiful.
mean a Mastiff?
Smaller than a Mastiff.
Great Dane?
Great Dane, that's it. Beautiful, bright blue eyes,
Aw.
and super sweet. But my youngest doodle, the Sheepadoodle Cup, and Vita, the Great Dane, they just don't know each other, and they can't see each other through that privacy fence. And they have now dug a hole because they're trying to get to one, they're scrapping and whatnot. So Amber and I that's my neighbor, we were talking, we need to get them over to a dog park where they're on equal
Aw.
Yeah.
so they can meet and figure out each other's smells and whatnot. But anyway, so I said, well, how's it going there, Amber? And she's got 3 daughters,
Thank
high
you.
school,
Right.
1 senior, 1 freshman, and then she has 1 in elementary school. And 2 of the 3 kids are now. So, and she's at home with them, and so it's the younger 2, and they One of them felt real bad one day and now has sort of recovered. The youngest, and she's pretty precocious. She actually came out the door without her mask, and Amber flipped out. It's because they have to wear their mask when they're in the house, but she's battling it right now. And it's spreading around. It is what it is. Again, I'm hopeful we can get back to the classroom, but right now it's not looking real good.
Yeah.
So I want to say this, if there's anything I can do to make this better for you guys and you're working in the virtual world, you're not going to offend me if you shoot me an email and say, hey, could you do this? Or, whatever. I want to try to make this the best experience as I can for you. You're paying for it. So there's that. All right. So
All right, thank you.
you're welcome. So game plan is finish up what you need to in 120. Take that test before Tuesday. Again, you'll get 2 swings at it right now. So at least take it once.
Mhm.
And then if there are problems that you have issues with, and if we're at a point that everybody has taken that test once, then I can go over test problems with everybody in class. If somebody hasn't taken the test, then that's not fair. I can't do that. So that's why I want everybody to have taken that test once, so you can actually ask questions in class on Tuesday. And then we will start into 3.A, uses and abuses of percentages. All right. All right, gang.
Sounds
So if you got nothing else for me, I know kickoff was about 12 minutes ago, 14 minutes ago. So I'll let you guys go get to the football game if you're into that. And have a good weekend. Be safe.
All right, thank you.
All right. See y'all.
Bye.
See ya.